The Soviet Union sent 28 missions to Venus in search of one impossible answer. Could life exist on Earth's deadly twin? Beneath Venus' toxic clouds and crushing heat, they found a world so hellish it seemed completely lifeless. But decades later, scientists may have uncovered shocking clues that even on a planet like Venus, life could still survive. In 1961, the Soviet Union launched Venera 1, the first spacecraft ever aimed directly at another planet. It was an audacious move, a declaration. We're going to Venus, and we're going to open it up. The spacecraft lost contact on the way there. Mission failed. They tried again and again. And in December 1970, everything changed. Venera 7 descended through Venus's atmosphere and touched down on the surface, softly, successfully. And for 23 minutes, it transmitted data back to Earth before the heat destroyed it. Those 23 minutes rewrote everything scientists thought they knew. Surface temperature, 475 degrees Celsius, hot enough to melt lead. And the atmospheric pressure at the surface, 90 times what we feel on Earth. To put that in perspective, that's the equivalent of diving 900 meters underwater. The weight of nearly a kilometer of ocean pressing down on you from every direction. Scientists sat with those numbers and came to a conclusion that was both obvious and devastating. Nothing can live on the surface of Venus. Nothing. But the Soviets weren't done. In 1975, Venera 9 and 10 pulled off something that seemed almost impossible. They transmitted the first photographs ever taken from the surface of another planet. Black and white images, grainy and ghostly, beamed across the void of space from a place no human will likely ever stand. The world expected alien jungles, vast swamps, something lush and bizarre. What they got was rocks. Sharp, jagged, angular rocks, strewn across a barren, alien landscape. Venus's surface looked like it had been torn apart and reshaped recently, perhaps by volcanic activity that was still ongoing. A planet not dead, but violently restless. And the clouds, the famous, mysterious clouds that had hidden all of this for so long? Scientists finally knew what they were made of. Sulfuric acid. Dense, thick, concentrated sulfuric acid droplets suspended in an atmosphere of carbon dioxide, swirling around a planet hot enough to be a furnace. The clouds weren't romantic or mysterious anymore. They were industrial, hostile, lethal. Then comes September 2020. Astronomer Jane Greaves and her team publish a paper in Nature Astronomy that detonates through the scientific community like a grenade in a library. They had been using the James Clerk Maxwell Telescope in Hawaii and the ALMA telescope in Chile to map Venus's atmospheric chemistry. Routine work, the kind of detailed observation that rarely makes headlines. What they found was anything but routine. Phosphine. One phosphorus atom bonded to 3 hydrogen atoms. A simple molecule, chemically speaking. But its presence in certain environments is anything but simple. Here's why phosphine matters. On Earth, it's produced in exactly 2 ways. The first is industrial. Factories and chemical plants synthesizing it deliberately. The second is biological. Microbes living in oxygen-free environments produce phosphine as a metabolic byproduct. You find it in swamps, in the guts of animals, in anaerobic bacteria doing their quiet, ancient work in the dark. In the atmosphere of a rocky planet with no factories, phosphine shouldn't exist. Every known non-biological process, lightning, volcanoes, solar radiation, meteorite impacts delivering phosphorus compounds, produces amounts so small they'd be undetectable. The numbers don't add up. They never have. And yet, Greaves's team was detecting 20 parts per billion of phosphine in the Venusian cloud layer. They ran through every alternative. They modeled lightning chemistry. They modeled volcanic outgassing. They modeled photochemical reactions driven by ultraviolet light. They modeled meteorite delivery. None of it, not even close, could produce phosphine in those concentrations. The team's conclusion, stated with the careful hedging that science demands, was that the phosphine might be produced by some form of microbial life floating in the cloud layer. The internet, appropriately, lost its mind. Here's where the story gets genuinely layered, because phosphine wasn't the only strange thing happening in those clouds. For decades, astronomers mapping Venus in ultraviolet light had noticed something that didn't fit. The clouds absorbed UV radiation in patterns that didn't match the known chemistry of sulfuric acid and water droplets. Something else was there. Something soaking up UV light that pure sulfuric acid cannot absorb. Scientists called these regions dark patches. And these patches are enormous, sometimes continent-sized. They move. They evolve over time. They shift and reorganize in ways that look less like static chemistry and more like something dynamic. Something that responds. In 2018, MIT astrobiologist Sarah Seeger proposed a model that was radical but scientifically rigorous. Those dark patches could contain microorganisms, tiny sulfur-coated life forms that have adapted to exist inside droplets of sulfuric acid, using ultraviolet light as an energy source the way plants on Earth use visible light. But Seeger went further. She proposed an entire aerial life cycle. Microbes live inside liquid cloud droplets at the habitable altitude, 48 to 60 kilometers up. As those droplets gradually descend into the lower atmosphere, where temperatures soar and conditions become lethal, the microbes sense danger and transform. They form spores, dormant, armored, nearly indestructible, and shed the droplet. The spores drift on convection currents, riding the planet's atmospheric circulation back upward, back into the habitable cloud layer, where they rehydrate and bloom back into active life. An aerial biosphere. Not on a surface, not in an ocean, in the sky. Living organisms completing their entire life cycle while floating in a planet's clouds, never touching solid ground. It sounds like science fiction. So, how can anything live inside concentrated sulfuric acid? It destroys organic molecules. On Earth, we have extremophiles, organisms that thrive in conditions that once seemed incompatible with life. Bacteria that live in boiling hot springs at Yellowstone. Archaea swimming in pH 0 acid pools in volcanoes. Microbes found on the outside of the International Space Station, exposed to the vacuum of space and solar radiation, not just surviving, but persisting. Life is, in the bluntest possible terms, extremely difficult to kill. Researchers studying the chemistry of Venus's cloud layer have run experiments specifically asking the question, can the building blocks of biology hold together in concentrated sulfuric acid? And some of the results are genuinely surprising. Certain organic molecules, lipids for example, which form the membranes of every cell on Earth, can maintain their structural integrity in acidic environments far more extreme than Earth norms under specific conditions. The chemistry doesn't require water the way we've always assumed. It requires solvents, and under the right conditions, sulfuric acid can play that role. Does that prove there's life on Venus? No. But it removes one of the most confident "that's impossible" arguments from the table. In 2021, NASA announced not one, but 2 new Venus missions. The first dedicated Venus exploration NASA has funded since the early 1990s. both approved within weeks of each other. The scientific community had clearly made its case. DAVINCI, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, will plunge a probe directly through Venus's atmosphere, sampling the cloud layers in extraordinary detail on the way down. It will pass directly through the altitude range where life has been theorized to exist, measuring the chemistry in real time with instruments specifically designed to detect biosignatures. VERITAS, Venus Emissivity, Radioscience, INSAR, Topography, and Spectroscopy, will map the surface in unprecedented resolution, helping scientists understand Venus's geological history and what processes might be driving its atmospheric chemistry. If there's something unusual happening in those clouds, VERITAS will help connect it to what's happening on and beneath the surface. The European Space Agency added their own mission, EnVision, a coordinated effort to study Venus's atmosphere and surface in tandem with NASA's probes, creating the most comprehensive scientific campaign ever directed at our nearest neighbor. And Sarah Seeger, still at MIT, is leading a private mission concept called the Venus Life Finder, a series of small, focused probes designed specifically to search for signs of life in the clouds. Not geology, not mineralogy, life. These aren't wishful thinking. They're funded, they're in development, and they're aimed at answering, once and for all, the question that a radio signal in 1956 first planted in the back of humanity's collective mind. Step back for a moment, because the Venus question isn't just about Venus. Right now, our best candidates for extraterrestrial life in the solar system are Mars, for its ancient riverbeds and possible subsurface water, and Europa and Enceladus, for their liquid oceans locked beneath miles of ice. Compelling candidates, but they all depend on a very specific recipe: liquid water, certain minerals, protected environments. If life can exist in the sulfuric acid clouds of Venus, sustained aerially, without a surface, without liquid water as we understand it, then every assumption we've been making about where life can hide gets thrown out. Suddenly, the thick cloud layers of gas giants become candidates. The nitrogen hazes of Titan become more interesting. And most significantly, the billions of Venus-sized rocky exoplanets discovered by the Kepler and TESS missions, planets previously dismissed as too hot, too hostile, too Venus-like, all get a second look. Astronomers estimate there are billions of rocky planets in our galaxy roughly the size of Venus and Earth. If even a fraction of them host aerial biospheres, living ecosystems suspended in their clouds, then the universe becomes a very, very crowded place. The math on cosmic loneliness changes completely. Let's be honest about what we have. We have phosphine in Venus's atmosphere, confirmed at low concentrations, still without a fully satisfying non-biological explanation after years of effort from some of the best atmospheric chemists in the world. We have UV-absorbing dark patches in the cloud layer that behave dynamically and don't match the known chemistry of the clouds. We have a theoretical aerial life cycle proposed by credible, credentialed scientists, internally consistent, falsifiable, and still standing. We have chemistry research showing that life's building blocks are not necessarily destroyed by sulfuric acid under certain conditions. We have multiple space missions funded and in development, aimed specifically at these questions. And we have an entire scientific community that went from dismissing the idea of life on Venus to actively, seriously debating it, which, in science, is a seismic shift. What we do not have, and intellectual honesty demands we say this clearly, is proof. No microbe, no cell wall, no metabolic signature, no DNA analog. We have unexplained signals and compelling theories. But here's the thing, that's how it always starts. Every great discovery in the history of science began as an anomaly. A number that didn't fit, a signal that shouldn't have been there, a result that made someone say, "Wait, That can't be right. For most of human history, we looked up at that bright point of light in the morning sky and called it the evening star. Ancient civilizations worshipped it. Poets wrote about it. Galileo trained his telescope on it and discovered that planets have phases just like the moon. And this whole time, if the evidence holds up, there may have been life up there, floating in the clouds, cycling through spores and droplets, completely indifferent to the fact that an entire civilization below them was naming constellations, writing poetry, going to war, and never once imagining that the brightest star in their sky might not be empty. We almost never looked. Venus was written off as a dead world, a cautionary tale about greenhouse gases, not a candidate for biology. It took one team, one telescope, one unexpected signal, and suddenly the conversation that had been closed for decades blew wide open. That's what science does at its best. It doesn't just confirm what we suspect, it finds what we never would have imagined. The Venera probes showed us the hell beneath the clouds. Now we're going back, better equipped, sharper questions, open minds, to see what might be living in them. The missions are coming. The data is coming. And within the next decade, the planet that kept its secrets for so long may finally have to answer. Venus is waiting, and so are we. So, if you enjoyed this video, make sure to hit that like button, share it with your friends, and don't forget to subscribe for more amazing content.